Okay, we're going to find the area of a circle. Seem pretty straightforward. Oh, we'll be using calculus. And of course, x squared plus y squared gets us a circle as long as it's centered at the origin. Now, if it is not centered at the origin, then we have to remember that we've got x minus h quantity squared plus y minus k quantity squared equals radius squared. We're going to keep it straightforward today, though, and we are just going to have a circle centered at the origin. And of course, if I've got that 100, I better think about, well, what's the radius? Well, the radius is 10. All right, so x squared plus y squared equals 100. In other words, x squared plus y squared equals 10 squared. So we need a radius of 10 on a circle centered at the origin, and we've got to try to find the area of a circle with radius 10. I wonder what the answer is going to be. Well, you know what we got to do first. All right, I need to know exactly what am I looking at to set up the integral. And so I'm going to shade in the circle so I know what I'm looking for. And it looks like from left to right, we'll go from -10 to +10 on the x-axis. And then we're going to cut this up into rectangles. And of course, the width of the rectangle is just dx, but what is the height of the rectangle? Well, I need to have the function that defines the top subtract the function that defines the bottom. So let's solve for y. Right? I need y equals. Uh-oh, that's not really a function because there's a plus or minus. That's okay, I can split it up. That is the function that defines the top half of the circle. There is the function that defines the bottom half of the circle. Let's set up our integral. We're going to go from -10 on the left to +10 on the right. The height of the rectangle is that positive square root, and then the bottom of that rectangle is that negative square root. So if we want the height, we got to do top subtract the bottom. Hey, subtracting a negative becomes just a positive. We've got two of those square roots, so this looks like it won't be that bad to work through. Of course, I need a triangle. We'll humorous Bob Ross situation. Let's move the integral toward the top of the page. Let's get our triangles. What are we looking at? Well, it appears we're looking at one of the legs. So x is going to be one of the legs. And if you remember from the last time we did the trig substitutions, this was the one substitution that worked out nicely enough that we could actually solve the integral with our basic integral skills. 10 has to be the hypotenuse. And then there is our other leg. All right, so sine of theta has to be x over 10. So x can be substituted with 10 sine theta. Take the derivative of x, and we know that dx can be substituted with 10 cosine theta d theta. Oh, we need our limits. Okay, well, if sine is x over 10, I should say sine of theta is x over 10. I know theta has to be arc sine of 10 over x. Well, let's plug in -10 and find our left-hand limit. And it looks like it's going to be -pi over 2. What? Some confusion out there? Wondering what happened? Okay. If I wanted to solve an equation, such as sine of theta equals -1, of course I'd declare that the answer is 3 pi over 2. But here's the issue. We were asked to try figure out the arc sine, right? The inverse sine function. So when I solve equations, I want to start at 0 and go to 2 pi. But for the inverse sine function, the domain is restricted to negative pi over 2, less than equal to theta, less than equal pi over 2. So for arc sine of negative 1, I actually ended up going backward pi over 2 units. So that's why it's a negative pi over 2. And then, of course, for the right-hand limit, a little bit more straightforward. You expect to end up at pi over 2 when sine is 1. So let's put this all together. Left-hand limit, negative pi over 2. Right-hand limit, pi over 2. X, well, that's going to be 10 sine theta. Dx, well, that's 10 cosine theta d theta. Let's get some space. And let's square the d squared. All right, 10 times 10 is 100. The other 10 times 10 is 100. Sine theta times sine theta, sine squared theta. We're going to factor out that 100. And as we've done several times before, we're going to call on our ultimate Pythagorean identity for trigonometry and figure out that 1 minus sine squared theta is actually just cosine squared theta. Now I can take the square root. Square root of 100 is just 10. Square root of cosine squared theta is just cosine theta. I see 2 times 10 times 10, that's 200. Cosine theta times cosine theta, cosine squared theta. Of course, we cannot integrate cosine squared theta. So once again, we're going to pull our double angle formula out here. And I'm going to solve for 200 cosine squared theta. All right, because I don't want cosine squared theta, nor do I want 2 cosine squared theta. I wanted 200 of them. So there is my substitution. And then I can perform my integration. And again, if you're scratching your head on integration, let's justify this. If I integrate 100 d theta, it'll just come out to be 100 theta. If I want to check that, if y is 100 theta, take the derivative, I get 100. The only reason why that looks a little bit odd is that you're used to working with x. Right? You know the derivative of 100x is just 100. So obviously if I start with 100 and take the integral, I'm going to get 100 in x. So that's what's going on with that theta. Now the other part, where is that crazy 50 coming from? Did I use substitution? Half of a du is d theta. And so that 1/2 times that 100 is where that 50 is coming from. And of course, if I integrate cosine, I'm going to get sine. Do my back substitution. Sure enough, there is 50 sine of 2 theta. Okay, let's get back to where we were. Get a little bit more room to work with. And now we need to evaluate. So I need to plug in pi over 2 for theta. Figure out that answer. Plug in negative pi over 2 for theta. Figure out that answer. And then I take the first answer, subtract the second answer. Okay. A lot of cancellations with those halves. Hey, sine of pi is 0. Hey, sine of negative pi is 0. Multiplication by 0 gets us some zeros. Adding zeros won't affect anything. Subtracting a negative just turns into addition. So 50 pi plus 50 pi is 100 pi. Of course, something's about to happen here. What does that A stand for? That's right, we were finding area. And if we are finding area, we need a label, right? This integral had context. We were trying to find the area of a circle, and so we're going to need some type of a label for that circle. If the radius is 10, the area is 100 pi. I wonder how I could have figured that. And so I'm going to put this all together on one slide. And so that way, if after watching the PowerPoint, you say, hey, I kind of got to see this, but I don't want to keep flipping through the video, there it is on one slide, and I'll have that available in both PowerPoint and PDF format. And of course, we're going to be left with our surprise, surprise message that we will have a worksheet to work on. And we're left with a scenic background here. So, nice little rock formation out in the desert. Through the magic of the internet, I can find all sorts of really cool things to look at.